All right, we're going to be talking about partial differentiation. So I'm going to be working out some examples of partial differentiation, and because this has multiple variables, this will be the first part here in Cal 1 where we've actually are working with multiple variables. And normally you wouldn't see this until you got to Cal 3 where we talk about multiple variables. However, for some reason in the business course calculus, they cover multiple variables, or they actually just covered partial differentiation. I guess it's just because it's something that they can do, not really having to know much about the theory or definitions or any of that kind of stuff. So I'm not going to talk about any theorems or definitions here. I'm just going to show you some examples, and there is some good geometric things to show to better understand partial differentiation, but I think in these 5 problems or whatever I'm working out here in this section, I'm not really going to talk much about any of that. So we're just going to be doing partial differentiation and just looking at the mechanics. Alright, so I've got my function f here of xy, and it's defined as 2x squared y plus 2y squared x. Let me just say this, that you might try going to some algebra system and graphing this, and at least seeing what the graph looks like. Of course, it's going to be in 3 dimensions. Alright, this notation here, okay, it's not as bad as it looks, I promise. The way this reads is this is the partial of f over the partial of x and the partial of x, partial of f, partial of y, partial of y. Okay, I guess, I don't know, I'm not going to go through all that, but let's look at, I think I worked that one there first. Right, so we're going to be looking at the partial of f over the partial of x and the partial of x. All right, so which one do we do first? Because you notice we're either going to be doing this one or this one here. So which one do we do first here? Let's scroll on down. You might want to write that down actually. Pause, write that down. Okay, see if I can remember it. I guess never mind, I actually rewrote it here. It's been over a month since I actually worked this stuff out, and I'm just now getting around to recording it. So anyway, we're working this one here, and we're going to be looking for the partial of f over the partial of x. So that's what we're going to do first. And here's our f here. Now, because we're taking the derivative of x, we're going to consider y to be a constant or a coefficient, however you want to look at it. And so what we're going to do is you're going to look for x here, and you're going to take the derivative, for example, of x squared. And you bring the 2 out front, okay, subtracting 1 from the exponent, and now we're left with 4xy plus, and now this y squared, because y squared is times x here, we just treat it like it's a coefficient, okay. So just pretend that this 2y squared right here is just all one single number. Pretend this is just all one single number here. So if this was all one single number times x, then what would the derivative of this be? Well, it would just be this one single number would be left, right? So pretend that's a 5 or something. So 5x, and the derivative would just be 5. But of course it's y squared here. So just pretend this is all one single number right here. Okay, so it's just the coefficient. Alright, now what we're going to do, it looks like I do some simplifying here. Now we're going to take the derivative of it again with respect to x. And so the derivative of x here is 1, but what are we left with? Just its coefficients, which is just becomes 4y. And then this is just a constant right here, and the derivative of this constant is 0. So what are we left with? We're left with 4y. Alright. Now what we're going to do is we're going to take the derivative, the partial of f over the partial of y, partial of y. So we're going to do the same thing, except this time we're going to be taking the derivative of y and holding x as either a constant or a coefficient. So the derivative of y here is 1, right? Derivative of y is 1, and then we're just left with its coefficient, which is 2x squared, plus, now you take the 2, bring it out front, 2 times 2 is 4, subtract 1 from the exponent, we're left with y, times, and of course it's just a coefficient, we just rewrite it, x.